Okay, so now that we've got congruency out of the way, let's start moving into similarity. But before we can get into similarity, we need to understand something called proportions. Okay, so what are they? So proportions are basically a ratio set equal to another ratio. Okay, so a ratio set equal to another. Okay, that is what a proportion is. So on number one, and before I get into that, let's read the directions maybe. Assess the validity of each equation. So I've got 1/2 is equal to 3/6. Okay, so let's assess the validity here. Is this true to say that 1/2 is equal to 3/6? And the answer is yes, absolutely. Well, why is that? There's several ways to tell, right? So 3/6 as a fraction, if you reduce down by, and I don't know why I wrote 2's. I was thinking 3 and I still wrote a 2. If you reduce down, you end up with, holy dog crap, 1/2. Okay? And if you drew a picture, okay, so there's 1/2, right? Well, 3/6 would look like this. 1, 2, 3 out of 6, and even the picture looks the same. Okay, there's one more way to prove. There's one more way to prove that these two are proportionate or are equal to one another rationally. Okay? And when you hear the word rational in math, it's just talking about ratios and or fractions. Okay, fractions are ratios. They're rational because you have a ratio of numerator to denominator, right? So this top number is your numerator, the bottom number is your denominator. The fraction 1/2 is a representation of the ratio of 1 to 2, just like 3 is to 6. Anyway, I digress. The other way to tell that a proportion is valid, right, is to cross multiply. Okay, so basically you're just going to circle like this with a little butterfly looking thing. You've done this before in 5th and 6th grade, and hopefully after that as well. But anyway, so we're going to do top times bottom, meaning 1 times 6, so that would be 6, is equal to bottom times top. So 2 times 3, which is also 6. 6 is equal to 6, and this proves the validity of this equation. So 1/2 is proportionate to 3/6. 2, 3, 4, and 5, I'm going to leave you to do as an exercise on your own. Okay, I'm not going to do those in this video, just keep the video short. If you have any questions over these, let me know, but make sure and do them for your own good. Okay, they're going to be a part of your notes when you submit. So if they're missing from here, I'm going to count off. All right, so get everything done that you're supposed to. So now that we understand what proportions are, let's talk about how we can use proportions to our advantage algebraically. And let's see exactly what I mean by that. So here I'm being asked to solve for x, right? And we're being told that these two ratios, 8 is to x as 15 is to 6, we're being told that they are equal to one another. And if that is the case, well, guess what we can do? We should be able to cross multiply and validate this, right? So 8 times 5 gives me 40. And 16 times x gives me 16. Well, 16x. I had a brain fart there. Anyway, what we're going to do next, we're going to divide by 16 on both sides to get x by itself, which you do to one side, you do the other. And you're left with x equals 40 over 16, which will reduce down by 8. So that's going to give me 5 over 2. Okay, and you can actually check your work. So 8 over 5 halves should be equal to 16 over 5. Okay, so all we're going to do, we're doing 8 divided by 5 halves, which is the same thing as 8 times the reciprocal of 5 halves. Put 8 over 1. That's going to give me 16 over 5, which is in fact equal to 16 over 5. Okay, let's do one more, because that one was a little bit ugly. I didn't intend for that one to be difficult, but I was really tired when I made this PowerPoint. Okay, so let's try number 2. Let's solve for x here. So 3 times 20 is 60. 5 times x is 5x. Divide by 5 on both sides. 60 divided by 5 gives us 12, and that is what our x is. And again, we can check our work by plugging back in here, just like we did on number 1. So 3 is to 5 as 12 is to 20. All you would have to do is cross multiply just like you did before. 3 times 20, 60. 5 times 12, also 60. And again, I'm going to leave 3 through 5 as an exercise for you to do. Okay, so moving on, let's apply what we've seen so far to triangles. Okay, so the proportionality part can come into play right now if we so choose. Okay, so I'm going to show you both ways to look at this on triangle 1 and set of triangles 1 and set of triangles 2. First, let's look at the common sense way. So this triangle A, B, C, and this triangle D, E, F are similar. Okay, well, how can I tell? How do I know? Well, let's look at AC compared to DF. And let's look at BC compared to EF. What do you notice? Going from 4 to 8 and 6 to 12. It's much like we dilated by a scalar of 2, exclamation point. Okay, so 4 times 2 gave me the 8, and 6 times 2 gave me the 12. So the missing side we're looking at, BA, should be similar to DE, right? It's oriented the same at least. So that times 2 should be equal to 16, which is DE, and it has to be. Now, the not so common sense way to do this, so let me erase and give myself a little bit of room. The not so common sense way to do this, however, this is still the way that you should probably learn. The not so common sense way to do this is to not necessarily think of it as dilation, but to think of it in terms of proportionality, right? So if we take the ratio of 4 to 8, it should be similar to the ratio of 8 to the missing DE, right? This is what we're trying to find here. Okay, so 8, here. Let's do 4, so long, we'll do short is to long, so 4 is to 8, as, again, we're going to do short is to long that we don't unknown. Okay, so this is short, this is long, this is short, this is long, this is short, this is long, short, long. You get the idea. Okay, so all we're going to do now, cross multiply. 8 times 8, 64. 4 times x, 4x. Divide by 4 on both sides. 16 equals x. which is the exact same thing we got, excuse me, the exact same thing we got when we used common sense. Okay, so looking at number 2, it's the exact same idea, right? We can think of it as a proportion, or we can think of it as, we call it, as a dilation. Okay, so let's look at the 21, the 24, the 7, and the 8. Well, how are we going from 21 to 7? And how are we going from 24 to 8? Well, we multiplied by a scalar of 1/3, didn't we? 21 times 1/3 gives you 7. 24 times 1/3 gives you the 8. So that means this missing side here, DE, if we dilate the 27 by 1/3, we're going to get this missing side DE. And we know that DE is therefore going to be equal to 1/3 times 27, which is 27 over 3, which is 9. So that's our common sense way of doing this. So what if we set it up as a proportion? We should come to the same conclusion of 9, right? Let me carefully erase all this here. Okay, so let's see if that's the case. So we're going to do 21 is to, brain fart, 21 is to 27 as 7 is to DE that we don't know. So 21 is to 27 as 7 is to DE that we don't know. All we're going to do now, so there's 2 ways to do this. And for the sake of not confusing you, but you could work smart and not work hard. But first we're going to work hard, and then I'm going to show you what I'm getting at. So first let's do this the hard way. So we're going to leave it as 21 over 27. So 7 times 27, that'd be 140 plus 49, that's 189, is equal to 21 times x. And we divide by 21 on both sides. And we get, holy dog crap, 9, which is what we should have gotten. Now, let's talk about what I wanted to do. So I could change this guy, I could reduce this guy down by 3, right? This would give me 7 over 9. And then if we cross multiply that way, so let me erase and I'll show you, we'll get the exact same answer. If we cross multiply that way, 7 times x, 7x, 7 times 9, 63. Divide by 7 on both sides. X is equal to, you guessed it, same thing, 9. Okay? So, in a nutshell, that's how we're going to apply proportionality to similar triangles. So here we've got some more examples, right? So I'm going to do number 2 for you. Number 1 and 3 I'm going to leave for you to do on your own. Okay, so here we're being told to assume that triangles A, B, C is always similar to the triangles D, E, F. Okay, so we're going to go ahead and use proportionality here. So 2, so we're going to say short is to long, so 2 is to 13 as short is to long that we don't know. Cross multiply, 2x is equal to 90 times 13, which is 1170. And we divide that by 2 on both sides. And we get x equals 585. And this answer should make sense, right? Because 2, if we look at this, right, this is dilated by a scalar of 45. So 2 times 45 gave us the 90. 13 times 45 gives us, you guessed it, the 585.